All right, I appreciate everybody's attendance this afternoon, this morning, wherever you might be. We're going to talk about, obviously, Amazon Web Services. We're going to speak about big data, specifically the building blocks with AWS. What I'd like to do is quickly just give you an intro in terms of Blazeclan, who we are. If you are not associated with us today, if you're not a customer today, a quick background. Blazeclan is an Amazon partner. We're an advanced consulting partner. We do professional services from our perspective, and really what we do is we try to engage organizations, customers of different sizes, and get them onto the cloud. I apologize, I didn't even introduce myself, so I should introduce myself. My name is Anuj Chetli. I am the Director of Business Development for Blazeclan for the Americas. Once again, focus on client partnership, client engagement, and making sure that from a business perspective, we understand what our clients are hoping to do when it comes to the cloud, when it comes to migrating to the cloud, and when it comes to operating on Amazon. Blazeclan, from a high-level perspective, we're very focused on big data with Amazon. We're focused on, we'll call it scalability from an e-commerce perspective on Amazon, and then we're also focused on really the plethora of Amazon services. So whether it's an assessment of your needs, or whether you already have 150 instances running on Amazon and require our assistance in terms of managing those instances for you, we do the full 360 when it comes to Amazon services. We are head officed in Pune, India. We have outlets and offices in Singapore, Malaysia, and in the U.S. We have team members all around the world that are really focused on business development, engineering, consulting from the various practices, and continue to really focus on leveraging our knowledge with Amazon. We've been a partner of Amazon for quite some time. We have probably about 3-4 years of experience in terms of consulting and doing cloud migrations to the Amazon Web Services platform. So getting into today's discussion, once again, we're going to talk about big data. We're going to focus on a couple of various services that Amazon has from a big data perspective, and I'm going to introduce you to our founder and president of the Cloud Consulting Group, Varun Rajani. Varun's going to take you through the high level and then deeper into the various services, and then what I will do with Varun is facilitate any Q&A that you might have, any questions that you might have, and get those answered for you. So Varun, I'll pass it off to you.
Thank you, Anuj, for the introduction, and good morning, everyone. I again welcome you to this webinar on building blocks for big data on AWS Cloud. So, big data, as you all know, has been in vogue for the past couple of years, and the adoption and the increase in the use of big data as a term as well as a set of technologies has increased hand in hand with the rise of cloud computing. And Amazon Web Services, of course, is one of the leaders when it comes to infrastructure as a service, cloud computing services. So what AWS has done over a period of time is that AWS has developed a lot of products, a lot of services which could actually help you to manage terabytes, petabytes of data using various different services. So the agenda for the webinar today is basically to introduce you to some of those services on a high level. Of course, if you have any more queries, if you are interested in any of those queries, just drop us a note and we would be happy to answer all your queries on AWS as well as big data on AWS. So the flow of the presentation would be we'll just have a brief introduction about what big data is, the 3 V's of big data. We'll talk about why cloud is big data's best friend. As I said, the rise of big data and the rise of usage of big data has increased with the rise of cloud computing. So there's of course a lot of synergy between them. So we'll talk about that. We'll briefly discuss on the different phases of big data lifecycle. And as I mentioned, we'll talk about the various services on top of AWS which you could basically use to develop your own big data solution. And finally, we'll talk about Cloudlytics.com. Cloudlytics is an online big data platform developed by Blazeclan. So we'll just give a brief overview on how we're using big data for a SaaS product. So let's start. So what does big data, right? So basic question, I'm sure most of you know the standard definition. Big data is data which cannot be processed by the current tools and technologies, which would include both hardware and software. So big data is too big, too fast, and too varied. Right? So something which probably our traditional data warehouses or traditional databases, relational databases would not be able to handle, or our the on-premise infrastructure would not be able to handle in terms of capacity. So that what is big data. So big data could be defined by these three V's, or the three characteristics of big data, which is volume, variety, and velocity. By volume, of course, we mean that the amount of data basically which is generated, right, is increasing day by day, and we are now connected to the internet. We are now living in a digital information world, wherein every point of contact that we have with technology creates a lot of data, right? So take your telephone, take your mobile phones, take your televisions, take your microwaves, we take your cars, aeroplanes, anything that we engage with in terms of technology today generates a lot of data. So the volume of data is basically multiplying day by day, and the volume is basically, data is basically exploding today, right? So first characteristic of big data is the volume, right? We generate a total of 2.5 quintillion bytes of data every day. Just to put it into perspective, this is the same amount of data which was created for the first 20 years of the internet. So what we created in first 20 years of internet, the amount of data we created in a single day, in less than a day, right? So we're talking about huge volumes here. The next characteristic of big data is the variety. By variety, I would mean there are a lot of ways, there are a lot of places from where the data is being generated, right? And each source of data where the data is generated will have different forms of storing the data, right? So for example, on a social network, you would have photographs, you'll have comments, you'll have likes, etc., right? Similarly, on your web server, there would be different set of formats for your log files. For web servers, there would be different set of formats for your database log files. Similarly, with the rise of Internet of Things, sensors create a lot of data which would be again in a very different format. So variety of data which probably could not be handled by a relational database, because in a relational database we need to predefine the data model before we actually start using a relational database. So if we have data which is of varied formats and which cannot be predicted beforehand, relational database is probably of no use. So that's again the second characteristics of big data. And the final characteristic of big data is, of course, the velocity. Just because we are creating huge volumes of data every day, the velocity or the speed at which the data is created is, of course, too huge, right? And where the bottleneck comes in is the hardware infrastructure which we require to process this huge amount of data at the speed at which it is generated is almost impossible. So that is the third characteristic of big data. So this is how we would define big data with these three characteristics, right? Some of the examples from the internet on how much data is generated every day, right? Walmart generates 2.5 petabytes of data every day. Facebook generates more than 1 billion pieces of content, so that again is petabyte scale data generation every day. So big data is getting bigger and bigger, and in today's world, in today's information technology world, information plays a very important role. So whether you are a big business or whether you are a small business, information will help you in taking the right decision. And if you are not using any of the big data technologies, you are losing out, right? We'll talk about how cloud is big data's best friend, and how even a small company or a small or medium enterprise could take advantage of cloud computing to process big data, and that really puts them in a level playing field vis-a-vis the large corporations. So Walmarts of the world probably had big data processing capabilities since say last few many years. But if I'm a very small chain competing with Walmart in my locality, today I could use cloud computing and basically generate a lot of analytics, get understanding of my customers better, and maybe even compete with the big boys of the world. So why is cloud big data's best friend? Let's talk about it, right? As I said, cost of data generation is falling rapidly. Today we see data being generated everywhere, right? Previously there were limited sources from where the digital data used to be created, but today it's everywhere. Data is everywhere, right? So because the cost of data generation is falling, a lot of data is being generated and everybody wants to now process the data. So but what it does is, in the traditional architecture, as I mentioned earlier, your hardware probably would not be able to handle the data which is generated right now at the speed at which it is generated, right? And even the software or the traditional relational database services or database softwares would not be able to handle the variety of data which is being generated by your traditional hardware and software. So there is a bottleneck which gets created once the data is generated to process it and to store it. So that is where cloud comes into the picture. So the basic characteristics of cloud, like elasticity, like on-demand, like scalability, help you in overcoming all of these, the hardware infrastructure problems, right? Now, because by using cloud computing, you get enormous scalability, and because it is on demand, and because you are not paying anything upfront for any of the hardware infrastructure, you could basically, launch clusters of virtual machines, virtual servers to process virtually any amount of data that you could imagine that you could generate. So all of these characteristics of cloud basically are also very much essential for processing big data, right? If there was no scalability, I would still be with the stuck with the problem of adding more hardware, which is again very expensive and which again goes out of reach of most of the organization. But with cloud, that limitation goes away. So cloud and big data, traditionally, if you see the growth of both of them in the past few years, past 4 to 6 years, you'll see a parallel rise in the usage of both the things. This is because there are these synergies which help them to grow together. Also, cloud helps you in optimizing your IT resources. So, the most precious IT resources that you could have in your organization are your DBAs, are your skilled resources, are your data scientists, your programmers. And you cannot afford that these resources being wasted in doing the heavy, undifferentiated heavy lifting. So cloud basically makes it easy to deploy a big data solution. So now traditionally in the old IT world, if you are implementing a big data solution, out of say 100% of your resource utilization, you would be spending 70% of your resources in just ensuring that you have the right infrastructure in place, you have the right kind of softwares in place, you have the right kind of processing equipment in place to process the big data. All that undifferentiated heavy lifting took 70% of your resource utilization, and only 30% of your time or 30% of your resources were being actually utilized to use big data or to implement actual solutions and get meaningful analytics out of big data. But with cloud-based infrastructure, that equation has completely reversed. Now, do away with the undifferentiated heavy lifting. You could pass it on to the cloud. With AWS Cloud, basically a lot of services are managed, so you don't need to worry about setting up your hardware infrastructure. You don't need to worry about scalability. You don't need to worry about distribution of your hardware, distribution of your resources. Even a lot of services like Amazon EMR, about which we'll talk in some time, basically help you in developing or writing softwares to process your data meaningfully using cloud infrastructure, because again the characteristics are same, distributed processing. So now your resources, your valuable DBAs or your data scientists could actually focus on the core problem, that is getting meaningful analytics out of the petabytes or terabytes or gigabytes, whatever the size of your data is, to get meaningful data insights out of it. So cloud makes big data easier to handle. We'll just talk about how cloud, or how AWS Cloud in particular, helps you do so. So before moving on, I'll just give you a brief of the big data lifecycle as is prevalent in the industry. So whenever you think of big data, you think of 4 phases of big data, right? The first one, of course, is the generation of big data. Now, as we've talked earlier as well, and I've been repeating it, data is being generated from multiple sources, and it is being generated in with tremendous speed, right? So that is the generation of data. That is the first step of big data. Because there's a ton of data which is generated, the next you need to collect the data from multiple different sources, store it somewhere on your infrastructure or on cloud, but you need to store it somewhere, collect it and store it. Once you store that data, you then need to process it. I mean, you need to analyze, you need to do certain computations to ensure that you get the final results. So once you get that analysis done or analytics done on top of it, then you have some meaningful information which is created out of that data. And once you have that data, once you have that information, you need to share it. You need to share it with your different teams. You need to share it with your end users to ensure that they make the right use of the data or the information which is generated out of your big data lifecycle, right? So this is a high-level process which you could think of for any data lifecycle management. Next, we'll talk about how AWS actually would help you in with all of these different phases of big data. So data generation is happening from a lot of places, a lot of different sources. There is structured data, there is semi-structured data, there is unstructured data. It comes in all sizes, it comes in all different formats, and it comes in tremendous speed. So because a lot of data is being generated, there is of course pressure being put down the line in your lifecycle management, because the input itself is too fast, too heavy for the subsequent phases to handle. But there are different tools and different services available to handle all of those load. First of all, to start with, we'll talk about how data generation and how data collection could be done on AWS using some of the services from Amazon Web Services. There are a few services that you could basically use to collect your data from different sources from where it was generated. The first and foremost service that I would like to talk about here is Amazon Web Services import and export. So import and export is not a typical traditional web service as per the definition. Import and export basically is a service from Amazon which allows you to copy huge amounts of data, which probably if you would be transferring that data from your data center onto cloud using, say, your internet bandwidth, it would A, cost you a lot, and B, it will take a lot of time. So just imagine if you have, say, 100 GB of data which is generated every day on your on-premise database. To move that amount of data, you need very high bandwidth. So to avoid this problem, Amazon Web Services import-export service allows you to copy that 100 GB of data onto a hard drive, onto a portable hard drive with certain predefined formats, and you could basically ship that hard drive onto AWS data centers, and AWS would then copy that data onto their local servers and then give you the access. So that so the amount of time that you would take basically to upload terabytes of data onto cloud is reduced by a few days using import and export. Similarly, if you want to export data from AWS to your local on-premise data center, and if the size of data is huge, you can again use import-export service. The next service is the Amazon Web Services Direct Connect. So Direct Connect is a dedicated network connection between your on-premise data center and onto AWS. So what it does is basically you could have a dedicated lease line between your on-premise data sources and your on your cloud data storage services. So which would ensure that the movement of data between these two locations is pretty quick. The only limitation of Direct Connect is that it is not very widely available across regions, and it is only available in a few geographical regions. And the final service to collect or transferring data onto AWS cloud is called Amazon Storage Gateway. So Storage Gateway is a service which basically allows you to mount your cloud storage services onto your on-premise infrastructure just as a additional storage device on your hardware. So you could actually mount simple storage service onto your on-premise infrastructure as a additional storage device. What it basically does is, or how it helps is that any data you copy onto the storage device gets copied directly onto the cloud. So of course there might be certain cases where the latency may become an issue, but if you're planning to take backups, or if you're planning to move bulk data in batches or in bunches, you could probably use Amazon Storage Gateway. So this is probably how you collect data using Amazon Web Services Cloud. Next, we'll talk about the storage of data on AWS Cloud. Right now, I'm sure if you are an AWS user, you would be aware of the service called Simple Storage Service, or S3. S3 is basically storage for the internet. It's an object store. By object store, I mean it's not a raw block store, but it actually allows you to upload files, upload media, upload objects onto the S3 storage space, and give you unique URLs for each of the object which is uploaded. So S3 allows you to store objects of size of minimum 1 byte, and the maximum size that S3 allows you to store for a single object is 5 terabytes. So imagine if you have hundreds or thousands of log files generated every hour, you could basically dump them into S3, and S3 is a very cheap and very reliable storage service to store all of your objects, including log files. The next service for storing data on AWS is the Amazon Relational Database Service. As the name suggests, it's a relational database service. The advantage here is that it's a managed database service. So what it means is, if you use Amazon RDS, or Amazon Relational Database Service, you need not worry about scaling up. You need not worry about taking backups of your backups of your database. You need not worry about the storage. You need not worry about the availability. Every single detail which is basically repetitive task for a DBA could be taken care of by automatically by Amazon RDS. So Amazon RDS supports 4 major relational databases, namely MySQL, Oracle Database, Microsoft SQL Server, and recently it announced support for PostgreSQL. If you are dealing with a lot of unstructured data, and if you are looking for a managed NoSQL data store, then Amazon DynamoDB is a good choice. Amazon DynamoDB is a fast, fully managed NoSQL database service that makes it simple and cost effective to store and retrieve any amount of data, and it and serve any level of traffic. So it is fully managed, it is 100% fault tolerant, and it's very fast. Right? So if you're looking for a NoSQL database, as we discussed, if there is unstructured data that you need to handle, DynamoDB serves very well for your requirements. So once you are done with generation, collection, and storage of data, you then finally need to process the data. Now, traditionally, how we process huge amounts of data is that we would run a batch process in the night, and the next morning when we come in, everybody is able to see the reports, right? But that was again that old school when you had on-premise infrastructure and when your software was not able to process your data in a parallel distributed manner. So we'll talk about one of the most talked about big data technology today. The big data technology which is talked about most is called Hadoop. So Hadoop framework is basically based on the MapReduce algorithm, which was published a few years back by Google, which basically allows you to parallelize and distribute your data processing across a cluster of instances or across a cluster of computers, so that your data set could be processed parallelly, and you reduce the processing time. Hadoop again is an Apache Foundation open source project. The only challenge with Hadoop is that it is very difficult to implement it, right? Setting up a Hadoop infrastructure is not that easy. You could probably take a few days or a couple of weeks to set up Hadoop, and then again maintaining Hadoop, ensuring that every time you run a job on top of Hadoop, all your hardware infrastructure is up and running, you take care of fault tolerance, etc. It's a tad bit difficult. What AWS has done is that it gives you an managed Hadoop service on cloud, basically Hadoop on cloud, right? Hadoop as a service, and that service is called Amazon Elastic MapReduce. EMR or EMR. So Amazon Elastic MapReduce or EMR is basically a managed Hadoop distribution, which uses a customized Hadoop framework, but it gives you all the features of Hadoop, except that you don't need to worry about setting it up, or you don't need to worry about managing your clusters or managing your hardware infrastructure, etc. AWS will take care of it. It again uses MapReduce. And what EMR also does is it basically allows you to process files which are stored on Amazon S3, right? So Hadoop basically works on its own set of file system called HDFS. So you could even set up HDFS for Hadoop on AWS, or you could even store data on Amazon S3 and use it as a file system for EMR on AWS. And EMR, because it is managed, it saves you a lot of cost when it comes to administration part of it. You of course will need to write certain jobs to ensure that you can process the data the way you want, and then you could also use a lot of tools and methods to ensure that you optimally use the EMR infrastructure on top of AWS. So if you're looking at big data, probably EMR will play a key role in your whole big data story. Finally, once you have analyzed or transformed your data using Amazon EMR, you need to basically store the analyzed data into some kind of data store and then share that data with your end users. So you could store data again using the Amazon Relational Database Service, or RDS, which we talked about. So if your relational database could handle tons of data, you could probably dump that into RDS. Or if you're looking for a data warehousing solution, you could have a look at Amazon Redshift. So Amazon Redshift is a fully managed petabyte scale data warehouse available as a service on top of AWS. The way AWS has architected Redshift is that it is a massively parallel processing. It has a massively parallel processing architecture, and query that you fire on Redshift basically gets distributed across multiple nodes depending on the size of clusters that you have selected, and it improves your query performances. There are other architectural features of Amazon Redshift, namely that it's a columnar data store, which would mean that your data is not stored in blocks of rows, but rather it is stored in blocks of columns, which again makes retrieval of data for analytical processes much faster. So all of these things make Redshift a very fast data warehouse application when you compare it to, say, the likes of Oracle data warehouses, right? Again, the major advantage of Amazon Redshift is that it is priced very competitively. So if you, for example, take 3-year reserved instances on Amazon Redshift, you could basically end up paying less than $1,000 a year for a terabyte of data, right? If you could compare it with the traditional on-premise data warehouse solutions, probably that figure would be at least 10 to 15 times more than what Redshift gives you. So Redshift is again a good way to store your data once it is analyzed. It's a very fast data warehousing solution. When it comes to sharing your data, Redshift is able to connect with most of the leading BI tools available in the market today. You could connect it with Jaspersoft, you could connect with Pentaho, you could connect it with Tableau. Any leading BI solution could be integrated with Redshift. Also, Redshift comes with ODBC and JDBC connectivity, so that again makes it easier to connect it with different set of programs that you may have written for processing your data or sharing your data. These were the services which basically help you in generating, collecting, storing, and distributing your data, your big data, right? The only challenge that now remains, which needs to be addressed, is that if you have so much of data, if you have so much of data moving between different services on cloud, you need to write a lot of code, you need to do a lot of programming, you need to do a lot of automation when it comes to ensuring that all the data is being processed correctly and on time. So Amazon Web Services again has a service to do that, to make it easy for you to schedule jobs, to make it easy for you to retrieve failed jobs, to make it easy to connect to different data sources on top of AWS as well as from on your premise. That service is called Amazon Data Pipeline. It is basically a data management workflow which would allow you to move data from one service to other service on top of AWS. For example, once you have data on top of S3, and if you want to move that data to, say, RDS or DynamoDB or even Amazon Redshift, you could basically create, configure Amazon Data Pipeline without writing a single line of code and schedule it, and that's it. So every day or every hour or whatever is your schedule, Data Pipeline would process the data automatically and move data between one source to the other. Data Pipeline also supports some of the leading connectivity with some of the leading databases like MySQL and SQL Server. So if you have a MySQL database or a SQL Server database on premise, you could use Amazon Data Pipeline to connect to it, and it would even do data migrations or data movements from on-premise to cloud as well. So basically, to manage the whole data management lifecycle, you could use Data Pipeline along with the other services. Last week at Amazon Web Services annual developer conference and annual customer conference at Las Vegas called reInvent, Amazon launched a new service called Amazon Kinesis. So Amazon Kinesis is a fully managed service which allows you to process real-time streaming data at massive scale. So imagine if you are implementing a solution, if you have huge IT infrastructure and you want to implement a solution which would basically detect any kind of intrusions happening at various different places on your IT infrastructure. The only way you could do is probably using logs, right? So you need to process logs in real time to ensure that you figure out if there is any anomaly in the way your IT infrastructure is being accessed. Now if you have huge IT infrastructure, so would your logs be huge as well. So you could probably in that case use Amazon Kinesis to stream your log files in real time, and Amazon Kinesis will transform that data and help you store that data in one of those data stores which we discussed. It could be DynamoDB or Redshift or RDS. And once it is there in your data stores, you could basically run any type of analytical queries on top of it. So it allows you to generate real-time analytics on top of streaming data. Now, e-commerce companies could, for example, stream a lot of social media chatter and figure out the sentiments of users online, and then get those analytics and probably push an offer accordingly. So Kinesis could be a really helpful tool if you're looking to process real-time data. The best part about Kinesis is, again, it's a managed service, so you don't need to worry about the hardware infrastructure underlying it. You don't need to worry about the reliability of it. Everything is being taken care of, right? And Kinesis could scale up. It could scale up to support multiple terabytes of data every hour. So Kinesis was launched, or was announced rather, last week, and it is still available to a limited set of users. So if you're interested in exploring this service, you could basically go onto AWS website and request a limited preview of it. But otherwise, I guess it should be generally available over the next couple of months. So that's the end of the presentation. I've just put in a compiled slide for all the AWS services that we discussed, along with the different phases of data generation, right? So you have S3, RDS, DynamoDB for collection and storage of your data. You could use EMR for analytics and computation of your data. And finally, for sharing and collaboration, you could use S3 or RDS or DynamoDB or Redshift, basically any of those multiple different offerings for data storage from Amazon Web Services. So that's the end of the presentation part about AWS. I would just take a couple of more minutes to help you understand how we at Blazeclan have implemented big data solutions at multiple different places, including our own big data platform called Cloudlytics, which is Cloud Plus Analytics. So Cloudlytics basically is a pay-as-you-go software as a service based log analytics tool, and it is developed and deployed 100% on AWS, right? The way we are using various services, big data services on AWS, is that any log file that is generated, we bring it onto S3. So all the raw log files are stored on top of on S3. Once the files are stored in S3, we pick up those files using Amazon EMR. We do all kinds of transformation on top of it, and finally, once the transformation is done, we dump that data onto Amazon Redshift, and from Amazon Redshift, we have a reporting engine as a front end, which would basically generate a lot of interesting reports and statistics from the log files of the end users, right? We also use one more database, NoSQL in-memory database called Redis, which is not highlighted in the presentation, but again, which is because it's not a part of AWS, but we use Redis as a NoSQL data store, which NoSQL in-memory data store, and we use it for transformation of data, right? So we use it along with the EMR that we are using, and Redis is again hosted on Amazon EC2, right? So that's the end of the presentation from my side, including the case study. So I would be happy to answer your questions, and I hope that the presentation was a useful one for you.
Thank you, Varun. Yeah, we do have a couple of questions. So the first question, I'll reach out, and it's a technical question, so you absolutely can answer. So what's the data model behind DynamoDB? What does it support?
DynamoDB is basically a NoSQL database. By NoSQL, I mean it's a non-relational database, so you do not worry about data models. If you are talking about, or if you are looking at unstructured data, which would come in any kind of formats, you could basically use DynamoDB for it, right? So it's a NoSQL data store or a non-relational data store. I hope that answers the question.
Yeah, thank you very much. Question number 2, can I use EC2 spot instances with EMR?
Of course. So yes, you can use them. Just for the benefit of anyone who is not aware about spot instances and EC2. So EC2 is basically virtual servers on AWS. So EMR basically when it distributes your queries, it uses the Amazon EC2 as the computational nodes to process the data. And the way the spot instances work on EC2 is that Amazon has a lot of spare capacity which it would give out to its customers at a lower price. Only catch here is that you need to bid for the price, and if your bid is higher than the prevailing spot instance prices, you could basically use that capacity. So spot instances help you in reducing your EC2 costs to a large extent. So compared to an on-demand instance, a spot instance could easily save you up to 50-60% of costs. So yes, you can use spot instances with EMR.
So this is a good question, and it's a question that is asked quite a bit. It's about security. So what about the security of data that one collects and store on AWS? Can you speak to some of the security kind of ramifications or tightness that on Amazon Web Services?
Okay. Yeah, sure. So security basically on cloud, whether it be AWS or any other service, security would be a shared responsibility between the end users or the customers as well as AWS. So AWS will definitely take care of security when it comes to the hardware infrastructure, the physical infrastructure, the access points of their infrastructure or of their storage. But the user has to ensure that proper precautions or proper measures are taken to ensure that the data that they are loading on top of AWS is secured. Of course, AWS does provide you with a lot of tools and services which could make your data secured on AWS. So for example, any service that you use, whether it be S3 or RDS or Redshift or any other storage service on top of AWS, all of these services allow you to encrypt your data with industry standard AES 256 encryption standards, right? So any data that you store on AWS is encrypted, or you have an option to encrypt it. You also have an option to encrypt the data which is in transition. So some of these services will allow you to encrypt your data while you're moving it between your on-premise to your AWS service, or even between your various different AWS services. Again, then there are services like Amazon VPC or Virtual Private Cloud, which would allow you to create an isolated cloud of your own on top of AWS, right? So VPC again is widely used service, and it's again a very good security measure that you could make use of on top of AWS. And then there are a lot of other things that you could take care of. So if you have a specific requirement about security, maybe we can discuss it in detail. There are also a couple of white papers available. We have written a few articles which are available on our website, which detail out about on how to take care of security on AWS.
Thank you, Varun. Those are all the questions. Just for the attendees as well, so anyone that is attending one of our webinars, we are providing kind of a 2-hour consultation session free of charge for themselves and the organizations that they represent. So do not hesitate to reach out to us. Just let us know that you were a webinar attendee, and if there's any further clarification questions or a session that you'd like to have in regards to your cloud and Amazon Web Services need, do not hesitate to reach out to us. Also, please don't hesitate to go to our website. We have a posting of all our past webinars. We talk about, obviously, scalability. We talk about how cloud can help the media business. We talk about our product in terms of logging and capturing logs on CloudFront with Cloudlytics. And then obviously we have a focus on Redshift, one of the products, about today's session. So don't hesitate to engage with us, and we're here to help you. So anything that we can do to assist with your cloud strategy, please reach out to us. So thank you very much, and don't hesitate to visit our blog, and if there's anything that's required from an email perspective, please email us at info@blazeclan.com. So that really concludes our webinar for this afternoon. Wherever you are, whether it's afternoon, evening for you, or early morning, have a very good day. Thank you very much.